Let's go over your separation lab from today. There were hundreds of samples. I'm just going to pick one. Got sample 55. And this has, well, they all have some amount of sand, salt, and iron mixed in here. And that stuff is recorded in a spreadsheet. We're going to try to separate those three substances using physical methods based off differences in physical properties. So let's see how we can do that. First, I'm going to get a weighing cup to separate the iron. So I got a scale. This nothing in there. Zero that out. And I'm going to collect my iron in there. So I'm going to need a magnet because iron is attracted to magnets while salt and sand are not. I had a pile of magnets here. Just grab one of these in a sandwich bag, so as to not cover them up with iron. Now, I'm going to need both hands, so I need to change the camera angle. So I have to change the angle up. I'm going to reach in the plastic bag and pull the magnet away while the iron is in my cup, and it will just drop into that cup. I'm going to do that a few more times. All right, looks like I got all of it, or most all of it. Last little pieces. All right, so let's see what we got. I already zeroed my scale earlier. 2.73. Had to switch the camera angle again. So we got 2.73. Wrote that on the cup, and also I'll mark that on my board. Now back to the mixture we're left with is sand and salt. So how do we get sand and salt separated? What physical properties do they have different from each other? So hopefully you said salt dissolves in water, it's soluble, and sand does not. So that's what we're going to do next. Let's add some water to dissolve the salt in our mixture. Should have used warmer water because then it'll dissolve a little bit more. All right, but I don't know how much salt's in here, so we'll just put enough water to dissolve the salt. That's important, that you add enough water to dissolve all the salt. Now if you add a ridiculous amount, then you're going to waste time later, as you'll see, but it's important that you add enough water to dissolve all the salt. Next, now we have salt, water, and sand, liquid and a solid. How do we separate liquid from solid, or solid from liquid? That's right, filter. Let's grab a coffee filter. All right, so I have here a filter set up. And I got a coffee filter. I'm gonna wet this filter paper. That way it'll stick or stay in place when I pour my mixture through. And I have a beaker here collecting the liquid portion. I'm going to use a wash bottle, give it a few more rinses. All right, and I've gotten pretty much everything out of there. It's all either there, the solid sand, or down here, which is the liquid salt water. All right, let's take this guy over to dry. Stick that guy in the oven. The funnel will melt, so let's just take it out of there. And check back in 10 minutes or so. Now back here with the salt water, there should be no sand in the salt water. Nothing. Just salt water. Now how do we separate salt from the water? Well, they have different boiling points, so we'll use distillation. Turn this guy on, and just make sure our beaker is dry so it doesn't crack. Reuse, recycle. Okay. Check back in a few minutes. All right, it's boiling, but we still have some ways to go, so we'll check back in a few minutes. Still going. So got some ways to go. So let's check in on our sand. Should be close to done. Yeah, feels very dry. All right. What I should have done was zero out my filter paper. Nice and dry. Now let's go weigh this. Yeah, let me get another weigh cup. Now I'm going to need both hands to transfer this over, so I'll be right back. Just switched up the angle. So because this is nice and dry, it should just slide right in. I'm leaning on the table. 5.69. 5.69. So we separate the iron from the sand, and our last piece is to get the salt. Actually, let's write that on the board. 5.69. That was the sand. Let's see how. So now the water level is low enough where I'm going to start to see spattering. So I'm going to cover it up with a watch glass so I don't lose my salt, which is what I'm trying to get. So not much longer now. All right, let's turn this down. It is almost there. All right, turned off the heat. I'm going to let this cool. And I'm actually gonna move both of these to the dryer so I get all the water out. We'll check back in a few minutes. I gotta be somewhere soon, so let's just see how we're doing. Looks dry enough, probably. Well, don't burn yourself. And now I gotta take all that stuff out. All right. Change the angle up on you one more time. Got a new weigh container. Got that zeroed. Now I'm going to see if I can get as much salt in there as I can. It's, I'll give that a little more time to cool off. I have a spatula. And since I want as much of it making contact with the glass, I'm just gonna kind of roll a piece of paper towel around it. If I had a rubber spatula, I would. I think I might, but let's see if this works. That's still pretty hot, so I'm gonna see if I have my rubber spatula. All right, back with my rubber spatula, and at this point, even if it burns me, I'm running out of time, so I gotta do this. That's not gonna work well. Go back to my go back to my metal spatula. But the salt is really hardened on the glass, so I'll need okay. Yeah. Not bad. That. I didn't think it was going to come off that. Anyway. Well, this sample had a lot of salt. Now that's about all the time I have to fiddle around with that thing. So let's weigh this. It's already zeroed. 11.46. 11.46. So we've separated the iron from the sand from the salt. Let's see how we did. What did I just... salt. Well, I know that's wrong because I didn't give anybody that much salt. So that most likely means my salt was not dried. So I looked up on the spreadsheet. These are the amounts actually put in. So we can calculate percent errors. This is very little error. That might be a little bit of positive error balanced out by negative error. What I mean is, I know I didn't get all the iron out, but I did get a little bit of sand in there. And over here, I almost nailed that one. But again, that might not mean exactly that I did really well, but it could have gotten really close coincidentally because Maybe some salt got in there and some of the sand got into the iron mix. In any case, these are excellent results, and this last one was the most off because, like I said, I don't think that salt was completely dry, but I didn't have time to wait much longer for it to dry in the oven. So I'll show you how to do 1% error calculation using the one with the most error for me is the salt. So so the percent error goes as the absolute value of the experimental value, which is 11.46 grams. I'll leave the units out for now. Minus the actual amount is 10.13 over the accepted value, which is the true value, is 10.13 grams of salt is what was added by my TA, and multiply that by 100. So I need to use my phone, so I'll be right back. All right, I'm back. So that gives us, or gives me, a 13.1% error. And the reason I have three significant figures is because when you subtract here, you get 1.33, which has three significant figures. And had you gotten something like that, you would have gotten an automatic A, because you fell within the 15% threshold error.